Hey, welcome back for AP Chemistry. It's Mrs. Mays. Today we're working on equilibrium calculations, and we're going to spend some time working out a problem when you know the total pressure. I like these ones. These usually work out pretty slick. So in the reaction of phosphorus pentachloride at initial partial pressure of 189.2 torr, it's placed into an empty flask and allowed to decompose into phosphorus trichloride and chlorine gas. So the reaction given to us is at 557 kelvins, and we have an equilibrium value given to us. No, we're supposed to calculate the equilibrium value, but what we do know is the total pressure inside the flask at equilibrium. So we're going to use that to figure out the partial pressures of each gas once it's at equilibrium and the value of Kp. And of course, the whole thing has to happen at the same temperature or the equilibrium constant would change. So let's work this one through. First, we'll start by writing our reaction. Phosphorus pentachloride decomposes. So I'm going to not write any numbers in this column. Decomposes into phosphorus trichloride and chlorine gas. And this looks like a balanced equation. We're all set? All right, great. So initially I started with 189.2 torr and 0 products. But what I know is that some of my phosphorus pentachloride was lost in order to form an equal molar amount of phosphorus trichloride and the same number of moles of chlorine, because my stoichiometry is 1:1. So now let's put in our equilibrium values by adding initial plus change. 89.2 minus X is the equilibrium for phosphorus pentachloride. Phosphorus trichloride is just X, and chlorine is X. Now they've given us a total pressure, and the total pressure is going to come from the pressure from phosphorus pentachloride added to the pressure from phosphorus trichloride and the pressure of chlorine gas all together. That's a lot of P's in there, isn't it? Almost confusing. All right, now let's see. What do I know about these equilibrium pressures? I know that PCl5 is 189.2 minus X, and PCl3 is X, and PCl2 is also X. So these two X's can just cancel each other out. They go away. And the total pressure at equilibrium is also given to us in the problem, 358.7 torr. So really this worked out to be a very simple algebra problem. If I subtract the 189.2, then I can determine the value of X, where X now is equal to 169.5 torr. Well, that wasn't so bad, but now what do we do with X? Well, I know that X is equal to the pressure of phosphorus trichloride. So I know the partial pressure of this guy, 169.5 torr. I also know the partial pressure of chlorine because they're equimolar. So 169.5 torrs of this one as well. And on the other side, if X is 169.5, then I subtract 169.5 from 189.2 to get a partial pressure for phosphorus pentachloride of 19.7 torr. So now that I have values for each gas at equilibrium, I have something to put into my Kp expression. Remember, the K expression can only have equilibrium values in it, so it's important that we figure out the pressures at equilibrium. So I just cleared some space for us so that we can calculate Kp. It's going to be equal to the products over the reactants. So I have 169.5 times 169.5 divided by my reactants, 19.7, and that result is 1,460. And of course I don't need units because this is equilibrium, not kinetics. K in equilibrium, doesn't have units. But that's it. If you're given total pressure at equilibrium, it works out to be easy math. And you know, I like the easy kind of math. Great, so we'll try another kind of problem in part 4. See you guys later.